Hi, I'm Luis Mendivil. I'm from the audio productization team. We are going to show you our DAO Pro solution, which is a combination between for our next generation conferencing monitors. We are combining our current audio far-field voice solution with our device for computer vision. Here, what we're showing you is that our device, which is this guy, is able to capture multiple people, and we are displaying here the position and
That's you and that's me.
yes, this is myself, which is the main user. Here right now I'm about, let's say, 20, 40 degrees, and you are about minus 40, 30
And
degrees.
right now you're recording everything,
Yes,
right?
we are in conference mode, meaning that if the other person will be hearing us, let's say if we are in like a speakerphone area in a conference mode. Let's say if I don't want them to hear you, I will switch to personal mode, meaning that the beam is going to be really, really narrow and it's only focusing to myself. Here I'm showing you the microphone raw signal, which is capturing everything, like here in the background, and here is the output of our solution.
And if I say something right now, I'm talking from here, I'm on the side, and basically the line is very small.
Yes.
It doesn't listen to me.
Meaning that the other person in the far end, meaning at the end of the call, is not going to hear you.
And if you go on the other side, it's just going to follow you.
Yes, that's because of is the one who is saying, okay, where's the main user going? Right now, the current monitor solutions are assuming that the person is just in front of the monitor, meaning 0 degrees. But with this solution, we are able to just then dynamically move. Let's say if you want to grab something but to keep talking, or maybe you want to move to the desk next to it. And also our solution is capable of removing these annoying noises. I mean, it's not like you're going to do it, but like these annoying noises, or let's say
Nice.
If you're
Even if
happy-
it was a little bit in your direction, it would detect it's annoying.
yes. And let's say, if you're a gamer, can you help me type in dot keyboard?
All right, let's type here. It's quiet in the output.
Yeah, as you can see, it's really quiet, so meaning that the other person is not going to be annoyed by your typing, even though that's a mechanical keyboard that I don't know what kind of.
Nice.
So
This
yeah,
is so awesome. And in the future, potentially you could click on other people
Yeah.
and have choose who you wanted to follow.
yeah, that's all what we're working on. That's what we call the fixed beamforming. With basically, we are going to be able to select multiple people. Let's say we want to have maybe up to 3, 4, or 5 beams, and fix them into different angle directions. But
And is it possible you could do something with the speakers also?
yeah, that's possible. That's also something that we are working on, but first with the microphone, then with the speaker.
So then potentially the sound would only work for the person that you define has to hear it.
Yes.
That's also crazy.
Yeah, that's also going to be it. The first generation that we're working on is what we call voice ID. Basically, imagine that right now, instead of the visual recognition, is going to recognize my voice instead. So let's say whenever I say Alexa, I say, oh, this is the main user saying Alexa, not you or not him or not the other person.
And it just instantly knows where you are. It follows you.
Yes.
And all the other people ignores.
Yeah, yeah, because it's taking the angle information from the camera sensor that we have here.
And how clear can the sound capture be compared to, let's say, a headset? Mm-hmm. If somebody was wearing a headset or something, how clear could the sound be with following you this way?
Well, we have some data that we want to show you. This is some experiments that our team did in the lab. We did a similar experiment like what we're doing here, where we put some 2 distracted talkers in the lab. We put some primary user. We had some. Let me play it. Yeah. So let me play. This is the raw microphone.
Move the sheet to the dark blue background. It's easy to tell the depth of a well.
As you can
This stays that you can link
you can hear multiple people, and then so now let's play the what we call the process output.
The brush cannot leave the smooth lines. Move the sheet to the dark blue background.
As you can hear, the distractor talkers, which is these two guys, were removed from the process output. Now, we also have this other environment where it was more harsh.
The brush cannot leave the smooth
As you can see, it's this kind of environment like Tech Day, CES, where we have multiple people talking, a lot of noise, bubbling noise. And here,
Nice.
Move the sheet to the dark blue background.
even though it's really noisy and the speech was slightly distorted, but you are able to hear it. At least you will be able to hear it in the other end in the call clearly.
Is it important to also capture all the hertz, from the low hertz to the high hertz?
Yes.
Can you do that?
Yes.
Like you can have a really nice voice and not just like a mouse sounding voice.
Yes. Right now, our solution, what we are showing you is wideband, meaning that we are capturing up to 16 kilohertz. But we are working on our super wideband solution, meaning up to 32 kilohertz.
And everything is built in to here. Where's the microphone array?
Okay. So, and just to let you know, we are only using two microphones, which are these two guys embedded here inside the monitor.
Could it be higher quality with more mics?
Yeah. Our solution is capable of up to 8 microphones, but again, it's up to the manufacturer how many microphones that he wants. We have a manufacturer who wants to put more microphones on the back, so they are able to remove all the background noise from the back of the microphone, back of the monitors, excuse me.
All right.
So, but it's up to how much trade-off do you want to use, because you're going to have increase your boom, but you're going to have better performance. So but we are showing you like with just two microphones, we are able to do this much.
Nice. And this technology is what you also implement over there?
Yes, it's the same technology that we have there. Actually, here is similar. We have this small Teams control where we are toggling. Let's say if I do gesture control, I am able to do mute. And as you can see, it's just toggling between the icons based on the gestures that I do, like mute. If I do this stop, it's going to do like this raising hand. If I do this, it's going to pause my camera. So it's similar, if not the same, that we're showing you here. So we are combining these solutions into one single and making more attractive.